Hey everyone, I wanted to make a video quickly going over an introduction to software instruments and really just talk a little bit about latency and sound production. This isn't going to be the fanciest video in the world, as you can probably already tell, but I just want to explain some basic fundamentals and really compare what you already know about playing a piano or keyboard to what we do on Sundays and all of our services using software instruments to produce sounds and different samples. So let's just get started off with what you already know, right? And that is how a piano works. I hope that you like my artwork. I'm really a skilled artist. Anyway, so we all know that the main objective is to get sound to our ears, right? Your ears. Very exciting. When you want to get sound to your ears with a piano, it's pretty simple. You're going to start off by hitting a key, right? You're going to pick the key you want to play. When you hit that key pulls a lever, right, that is attached to the key. That lever throws a hammer that is attached to the lever, and that hammer will hit the string. And the string that you hit is directly related to the key that you press. It's very simple, 1-to-1. I press C, and it throws the hammer that hits the strings that are tuned to C. It's very simple, very straightforward, and ultimately what this is going to do is that it's going to send sound to your ears. You're like, Joe, you're not teaching me anything here. One thing you'll notice, I did write a little 3 ms right there, 3 milliseconds, because of the laws of physics and the speed at which sound travels. When you hit a key on a piano, it's going to take about 3 milliseconds for the sound to make it from the strings, the sound waves from the strings to your ears. And that's what we call latency, right? It doesn't really seem like it makes all that much of a difference. In fact, below 7 to 10 milliseconds, humans have a lot of difficulty distinguishing and really noticing latency. So 3 milliseconds, you and I, we can't notice it. We think it's pretty instant. And that's what happens when you strike a key that throws a hammer to hit a string, and then it delivers sound to our ears. When we're using software instruments to play different sounds, we're doing very much the same thing. Just track with me here. We're going to replace these levers and hammers and strings with a couple other things. So if we scroll over here, we can see the same thing starts off, right? We're going to start off with hitting a key, right? Simple, it's the same keyboard, maybe there are drum pads, but essentially there is some input, which is generally a key. What that key does now is, instead of throwing a hammer, right, pulling a lever and throwing a hammer, it's going to send a MIDI note. And what MIDI is, as you can see in there, it says key number and velocity. MIDI is just a form of data transmission, which has just got 2 numbers in it, right? So it'll either have a key number, so if you press middle C, I think it's key number 63, and it will have a velocity, and that velocity can go anywhere from 0 to 127. Why 127? I have no idea. I guess it's better than 100. So you'll send the information, right, the key that you press, instead of pulling on a lever, it will send MIDI information to your computer or to the computer that's built into the keyboard you're playing, and it will say, hey, you know, Joe Schmo just played key number 63 at velocity 100. So then the computer says, okay, cool, now I need to play a sound, right? Again, there's no hammer, there's no physical strings, it's not going to punch a string, instead it has to play a sound. You could be playing a drum kit, you could be playing a piano, you could be playing a Rhodes, or an oboe, or a flute, who cares? Whatever you want to play, the MIDI information that's transmitted to your computer, right? There's computer processing in here. The keyboard will tell your computer, hey, I played this MIDI note. Your computer then will say, okay, cool, I need to find that number of sample at that velocity. So a lot of times when you're playing a piano, someone will have sat down and recorded playing a piano very lightly and then very hard, and all of those different keys will then be, all those keystrokes will be recorded right here as these recorded samples. So the key sends MIDI information to the computer, and the computer says, okay, cool, I need to find key number 63, which is middle C, again, I think, and I need to find it played this hard at velocity 100. Cool. So I'm going to go and find it. I'm going to grab it. Now that I found it on your hard drive, I'm going to play it through your computer, and it's going to come out through an interface. An interface is really just a fancy way of converting digital audio to analog audio. So any headphone jack on any computer or phone, that is an interface. It's taking ones and zeros, digital audio, and it's converting it to analog so that it can make it, again, to your ears. So, to recap, striking a key sends MIDI information to your computer. Your computer says, great, I got to play that sound that hard. So it goes and it finds a recorded sample. Then once it finds a recorded sample, your computer sends that audio out to your interface, and your interface, whether it's a headphone jack or a more expensive or professional interface like something from Motu or PreSonus or Focusrite, it will convert it from ones and zeros to actual audio. And that whole process, I know I wrote it right there, but that whole process will take a certain amount of time, and then it will produce sound that you can hear. So you can see on the piano side, there's about 3 milliseconds just based on the distance between your face and the piano. On the software side, there can be a little latency or a lot of latency, right? Again, the latency is the time between pressing the key and hearing the sound. Generally, a strong, fast computer with a fast hard drive that's really moving and shaking will be producing sounds between 5 and 10 milliseconds. But that could increase, right? You can see the computer processing over here. Instead of just being simple mechanics like a lever and a hammer, you've got a computer processor that's looking for a sample. And then once it's found that sample, it has to send it through the program you're using, if it's MainStage, or again, even if it's just an electric keyboard, electric piano, it has to send it out to the interface, and that interface has to convert it, and that will take a certain amount of time. But ultimately, it does the exact same thing, and I hope that makes sense overall. Essentially, we're mimicking what a physical piano does, and hopefully you can see the connection between how we do that on a digital side, how sound is produced in a similar way, and how, because it's not as simple, all the different steps in there, all the different computing and processing will create latency, but we want to try to keep that as low as possible so that the sound is produced as quickly as possible. We have the most enjoyable playing experience, and it's a great listening experience for everyone else. So hopefully all of that makes sense. Hopefully I've answered a couple questions or made this whole process seem a little less foggy. But if you have any more questions, let me know, and there'll be more videos to follow.